Hello, my name's Abi, and today is the second math video where we're going to be talking about linear functions and systems of two linear equations in two variables. So first, for linear functions, we're going to do the same thing as the last video where we're going to go from easy to medium to hard problems. And so for the first problem, we have the function f is defined by f of x is equal to 8x. So for what value of x does f of x equal 72? And so we can just plug them into each other because they define the same term, f of x, where x is equal to 9. So it's b. Are fairly easy. Now for the medium problem, it gives us that f of x is equal to 39, and it asks, for the given linear function f, which table gives three values of x and their corresponding values of f of x? So here, if f of x is just equal to 39, no matter what x is, f of x is always just going to be equal to 39, and that's why it's b, because all these values are just 39, and that's all the other ones are wrong. Alright, and then for the hard problem, we have, for the linear function f, the table shows three values of x and their corresponding values of f of x. Function f is defined by f of x is equal to ax plus b, where a and b are constants. What is the value of a minus b? So when it gives you a table and it gives you an equation, you're going to want to plug in a couple of these values here. And you want to start in with the one where it has a 0, because you want to isolate one of these two variables. So if we're going to plug that in, it'll be 0 is equal to 2a plus b, where negative 2a is equal to b. And you can plug this back in here to isolate a as a variable. So that would get you f of x is equal to ax minus 2a, where a is, there's no b variable here. And you want to plug in one of the other two equations or values. I'm just going to choose the first one here, where it's negative 64 is equal to just a minus 2a, because x is 1, where it would be negative 64 is equal to negative a, or a is equal to 64. And you want to plug this back into this equation to get b, where b is going to be equal to negative 128, and it wants us to subtract the two values. So it would be 64 minus a negative 128, or 64 plus 128, to get us 192, or d. Alright, now for the next topic, we have systems of two linear equations in two variables. So it gives us a system of equations, and it says the solution to the given system of equations is xy. What is the value of x plus y? So you can subtract, you can add, you can subtract these two equations. I'm just going to substitute because it's going to be easier for this one. So it'll be x is equal to 3, where you can plug this one in. It'll be negative 4, 3 plus y equals negative 2, where then y is equal to 10 if you do distribute it out. And so if y is 10 and x is 3, if you add them together, you get c, or 13. Alright. For the medium problem, we have a system of equations again, and it says the system of equations has a solution of xy. What is the value of x? So here, instead of doing anything to the first equation like I did in the last one, you can just immediately substitute it in, because it's 1/2 y for both. So it would be x minus 4 is equal to 2, where x is equal to 6, and it's just asking for 6, so it's d for this one. And then for the last one, we have another system of equations, and it says, what system of linear equations is represented by the lines shown? So here you want to look at the point of intersection, which here it's going to be 8, 0. And you just want to plug that in and see which one it doesn't, which one is false for, and eliminate that. So for the first one, it says, well, for here you can eliminate y for each one, because always just going to be 0, because y is 0. So 8 times 8 is 64, which does not equal 32 for both a and b. And then for c and d, 8 times 4 is 32 for both c and d. And for the second equation, negative 8 times 8 is already negative 64, so that's also right. So now that we're done with the point of intersection, we can move on to another variable, which in this case we can look at the the y-intercept, or the b value in y equals mx plus b, this one. So you have to make it into this form for both these ones, and I'm going to look at the bottom one because there's a negative here, and we want it to become a positive. So for c, if we put it into that form, it would be 10y is equal to 8x minus 64. And this one's just wrong because we have a y-intercept of negative 64 when it should be above the y, or the x line. So that's why C is wrong and D is the answer for this one. If you have a question, just comment. If not, thank you for watching.